This is part 2 of a water pump video done to investigate a low volume coolant leak for my Chev Suburban. If you got here first, click the appended link to go to part 1. Okay, I think we're ready to take the water pump off. We're going to take off these 3 bolts here and these 3 bolts here. 1, 2, 3. And we're going to pay careful attention to make sure they go back in the same order, and also look for evidence that any of these bolts might go through coolant passages which might require thread sealant. And let's lift the water pump out of the way. There it is there. Okay, it's a bit of a mess in here. You can see that I've taken off the hose here, which I think it was leaking right in there, and then the second hose here. And it's a bit of a mess in the back there, and so I'm going to take off the alternator for a better view. To remove the alternator, I'm going to have to disconnect the negative lead of the battery. Okay, we've got those 2 little hoses off now. I'll take you under here and show you. And I think that's the source of the leak up high. It may well have been leaking from the water pump as well, although I'm not seeing definite evidence of that from the weep hole. In any case, at this juncture, I'm going to clean everything up here with some engine degreaser, and then we're going to clean up the gasket bearing surfaces. Okay, I've been painstakingly cleaning this all off, and I think I'm getting somewhere. This is Scotch-Brite now, so we're just going to do the gasket surfaces, and I don't know if I would do this on an aluminum engine block. I think I'd probably do it all by hand with a razor blade, but with a steel block I'm perfectly fine with Scotch-Brite using this technique. Okay, looks like we're getting close here. See that steel pipe that was up above? That steel pipe was quite rusted initially, and now it's not bad at all. There's no evidence of any breakdown at the point of leakage there. And then further down, the mating surfaces look pretty good. A little bit more work to do there, but we're almost ready to put the new water pump on. So here's our new water pump. I've swapped over the bolts. They all were about the same length, and they looked pretty much the same to me. And our old water pump, and I'm not seeing any significant difference. These look identical to me. And here's the weep hole, and I'm not seeing a lot of leakage, particularly out of that weep hole. And the bearing of the water pump is good. And looking around the surface of it, you can see that white flecking. I'm not sure if you appreciate that, but that white flecking is residue from this leak. Was it leaking just in that one hose above the water pump? Well, it's possible, but look down here. That looks a little suspicious, and you can see it's all wet under here as well, so I wouldn't be surprised if we were leaking at this point. Now, I've gotten to myself to the point that the water pump is off and I've found the problem. I think one could raise the very interesting question as to whether or not I should try and put this pump back on and see if it'll work for me, but given the amount of work it takes to take this on and off, I can't see doing that. I'm here now. This is a water pump that's 13 years old. There are 300,000 miles or 300,000 kilometers on it. I've got myself to this point. I'm putting on a new water pump. Okay, next part is the hardware. This comes with a new gasket and an O-ring and a couple of bolts for the thermostat. And then on top of that, we've got a couple of metal-backed gaskets here for the openings. And these go on like this. Now, I tend to be in the camp that says, let's not put any RTV or any other sealant on here. Let's just torque it to specs, make sure it's nice and clean, and go from there. And through the years, I've been lucky with that. And not to say that I'm criticizing people who do otherwise, but it just seems more simple to do it without RTV silicone. So if you notice right here, it looks like in the factory this got bumped, and so the rest of the mating surface is fine. So I'm just going to file it down a little bit and take that burr off. This part's often a little tricky. So this is an inch-pound torque meter. The torquing for the first pass is 11 foot-pounds, the second is 22. I'm going to do the first pass with this one. 11 foot-pounds is the same as 132 inch-pounds. And so that's what we'll do now. And the second pass, 22 foot-pounds. We'll crisscross this one as well. So the thermostat on this vehicle comes together with the housing. And so it's all one unit. I'm going to reuse the same one. I don't see a reason to change it today. It would be easy to change at a future date if need be. Now I'm a little confused by the supplies because it supplied both a paper gasket and also the O-ring. Although the original had just the O-ring and with no paper basket. So I'm going to do it the way the original was, just with the O-ring, no RTV, and we'll bolt it together and see how it works. This is a new AC pulley belt. The tensioner is a bit sticky, but I think I can get it to work. I'm just going to turn the crank. This is a 24 millimeter to turn the crank and walk it on. I'm going to replace both lengths of tubing where I identified a leak. I borrowed a habit from a veteran to use a little bit of silicone spray on these to make it easier to get them on. And I'm replacing the clamps on these as well because the OD of the tubing is a little bit smaller with the new tubing. And let's use a mirror to check our connection. There it is there. Looks pretty good. And then on with the thermostat housing. And then the lower radiator hose. I tried to find a replacement for this, but there's no replacement easily available today, so we're going to reuse the old lower radiator hose. Then the idler arm pulley goes back on. And then the Serpentine belt tensioner. Next, the alternator. And then the Serpentine belt. Now I recently changed this, so I'm not going to change it again. Next comes the lower cowl. This hangs from two hooks, one here and one on the other side. So you just slide it into place. Next we're going to put on the fan. I can show you this tool. The distance between here and here is just a hair more than 1 3/4, and these knobs are just a hair more than 3/16 of an inch in diameter. And if you have that set up, or if you set it up with like an adjustable tool, then it'll work fine. And they've got a little rubber covering on the threads you take off so you don't damage the threads. And then we'll slide on the fan. And then once it's tight, good. I haven't been in the habit of using Loctite here. Next, the upper shroud. Okay, next I'm going to replace the upper radiator hose. The other one was a bit grungy. I haven't replaced the clamps. I suppose I could, but they seem to be working fine. Next is the Air Intake Manifold. I find this very interesting. You see this big bulbous thing off the side. I don't know if this is for cooling or some kind of resonance effect or perhaps increasing capacity, but all it is a blind passage here in this chamber. I'll clean it up first. Okay, this last part is really important. This is a 50-50 mix of Dex Cool and water. I did consider the option of switching to generic antifreeze, but I don't like mixing antifreezes, and this car has done really well with Dex Cool despite some of the reports otherwise. And so I'm not going to dismiss a good thing. So 50-50 Dex Cool and water, but the most important thing here is that we've burped the system. And so we'll fill it up, but there are going to be large pockets of air in the system, and they won't be cleared until the vehicle starts up, the thermostat opens, and the air bubbles are allowed to discharge back to the coolant reservoir and out. And so we're going to have to keep adding fluid until such time as our level stabilizes. And the reason it's very important is that if we made the mistake of allowing this engine to overheat, we could cause far more damage than we set up to do so. And so we want to be really careful about this phase. This hose isn't full yet, and so the thermostat hasn't opened, so we got to keep going until the thermostat opens. I'll be able to feel fluid here, and in the meantime we need to watch carefully that reservoir and make sure we don't end up dropping down too low, because as that valve opens, we could see a drop in fluid, or we could see a rise in fluid because there's an increased pressure in the radiator, and so we have to watch out that it doesn't overflow as well. Okay, we've reached operating temperature, and I can feel some warmth in the hose. Still feels like there's quite a bit of gas there. We've been quite stable for about 15 minutes now, and there's no coolant under the engine. I'm not seeing any leakage where the hoses meet, and there's no leakage at that other spot. I put a little mirror in under there. There's no leakage there, and so we've been running with the cap off. So what I'm going to do now is I'm going to put the cap back on, and what will happen is when I turn the engine off and the trapped gas is remaining, that trapped gas will contract, and as it contracts, it'll draw fluid back in preparation for expelling fluid. So basically the air that's trapped will gradually be disgorged over the coming days on a hot-cool cycle. It doesn't happen all at once, but I think we're at a safe state now where we can continue to run the engine, and we'll see how it goes over the coming days. I want to thank you guys for watching. If you found this video helped you out, please hit subscribe or like, or leave a comment to make it easier for others to find.